All right. I want to take a look here at the first example here of some rate problems. And again, hopefully you saw the video where I kind of gave an overview of basic rate concepts, because you're going to see a lot of those concepts showing up in this problem and in the other problems. One of the really important things on the AP exam that you notice over time is you do the same thing almost every year on every problem. The scenarios just feel so different. Sometimes you don't realize it until you've done several of these, and then you realize, oh, it's just always the same. Anyway, it says the rate at which rainwater flows into a drain pipe is modeled by the function r, where r of t is this sine function. Notice it's cubic feet per hour. Okay, so think about what's happening here. They're saying rain's coming in at 10 cubic feet per hour, 20 cubic feet per hour. This isn't the amount of rain, it's how much is coming in every hour. And if you notice, that's not a linear function, it's changing. Okay, it's increasing, it's decreasing over time. Now, the pipe is blocked. It allows water to drain out of the pipe. And they tell you the rate at which water drains out of the pipe is this right here. So imagine that we have water coming in, and just make up some numbers, just get an idea of what's going on. Maybe it's coming in at 10 cubic, was it feet per hour, I think? Yeah, 10 cubic feet per hour. And maybe it's going out at, maybe the pipe's not draining very fast. Maybe it's only draining 5 cubic feet per hour. Okay, think about that. Think about how much water is in the pipe over time. So anyway, part A just asks us to figure out how many cubic feet of rainwater flow into the pipe during that 8-hour time period. Well, this is a rate, okay? I know they call it R of t, but that's really a rate of change, which means it's the derivative of the function telling us the total amount of rainwater. So you might even want to label this. You might want to say like the total amount of water, uh, well, anyway, the big thing here, you want to think that this is a derivative. Okay, and if that's a derivative, we want to go backwards to the original function. We want to figure out the integral of this rate. Okay, remember we found the integral of velocities, which were rates of change, and that told us how much our position changed over a time period. Here we're going to find an integral of a rate of a derivative function over an interval, and that will tell us how much rain accumulated. By the way, think about your units too. We have cubic feet per hour coming in on one axis, and we have hours on the other. When you find an integral, you're finding an area. Cubic feet per hour multiplied by hours just gives you cubic feet. You can see that that would tell you the total amount of rainwater. So anyway, to set this up, you're just going to take the integral from 0 to 8 of your function, of your rate function. And anyway, I'll let you run the numbers on that. But that's going to tell you how much rainwater happens over those 8 hours. Now be careful, there's already 30 cubic feet in this. So this question just asked how many came in during that 8-hour period. The 30 won't come into play here. However, if they ask you like the total amount of rainwater in the drain, that might be something that you have to take into account. So anyway, I'm going to close this part out, and we'll take a look at part B in a separate video.